Now we are going to see the second problem in AC circuit. The question is, the circuit consists of a resistance of 25 ohm and a capacitance of 100 microfarad connected in series. A supply of 200 volt at 50 Hz is applied across the circuit. Find the current, power and power factor of the circuit. So the given data of from this problem, the given data we can write as resistance value. Resistance is 25 ohm and the capacitance is 100 microfarad. Voltage is 200 volt. Frequency is 50, right? And we should find the current, power factor and power. So from the problem I have drawn the circuit likewise, because the resistance and capacitors, both the element are connected in series and it is connected across the both the combination is connected across the supply 200 volt 50 hertz supply. Okay, so this is the circuit. Now so the voltage value given, the impedance value we need to find, right? The impedance in the given circuit is the form of Z equal to R minus JXC, right? JXC. So to find that, we have to substitute Z equal to, instead of R, 25 minus J, XC value. How will you find XC? XC equal to 1 by 2 pi FC. So 1 by 2 pi FC is, we have to use, okay, 1 divided by whole bracket 2 into 50 to, and pi value is 3.14 into capacitor value is 100 microfarad. So 100 into e power minus 6, then close bracket. Okay, so the answer is 31.847. Okay, the XC value is 31.84 7 microfarad. Sorry, 7 ohm, not microfarad. And the impedance is 25 minus 31.847. So this is the impedance value. Now it is in real and imaginary form. We have to write current equation. Current equal to voltage divided by impedance. So voltage is 200 volt they have given, but magnitude is not there, but it is in magnitude. Okay, that is polar form. Magnitude is 0. If it is not there, you have to take 0 angle. Okay, 0 angle. And the denominator impedance value 25 minus J, 31.847, right? So numerator is polar, denominator is rectangular. So I already said how to use the calculator in complex mode. So I have to see once again this, in the same problem I am going to do from the initial. So in numerator 20 and 0 degree, right? So polar, it should be in polar form. So open bracket, within the bracket I am going to type that number 200. Then for the angle symbol, shift, then this here angle is there, angle symbol is there, so I should press minus. Okay, so angle symbol K, then 0 degree, okay, right? 0, then close bracket, then divided by, in denominator 25, so within the bracket 25 minus 31.847 I, okay, 31.847, then I, close bracket. Okay, it came like that nicely. And so I want the answer in the form of polar. Okay, because to find the power, we need the magnitude value of voltage and current. So for finding the magnitude of current, I should get in polar form. So to get polar form, to see the answer, I am pressing the shift button. After that, uh, the polar. Okay, this is the polar. Then equal to symbol. So you will see the value likewise 4.939. Okay, 4.939. This is the magnitude of current. Okay, and see the angle. To see the angle, again shift, then equal to only. Okay, equal to symbol. So you will see here one angle symbol is there, and after that 51.86. that is mean by it is the angle. It seems this is the angle 51.867 degree. So this is the current and this is the magnitude. You are going to use this one only. Now power equal to VI cos phi. So V equal to 200 magnitude and current is 4.939, and the power factor value. What is the power factor value? We didn't find, right? Yes. For the current, we got the phase angle value. So this is the phi, right? So this is phi. Phi is nothing but what? 51.867. So from this you can find power factor cos phi. Cos phi equal to cos 51.867. 51.867. Okay, so 0.617. Answer is 0.617. This is the power factor value, and for the so we have to use this value 0.617 to find the power. So power is this value. Okay, what is the value? 200. We have to enter all these three. 200 into 4.939939 into 0.617. 0.617. Okay, then see the answer. See 609.47, right? So the power value is 609.47 watt. Okay, so this is the answer. So this is the way to find the power and power factor in complex and polar. Okay, thank you for watching this video.